Okay, let's go over everything that we need to know for our Chapter 2 test. You've done a lot of practice problems, you've done a lot of discovery through all this, but let's just summarize it and see if we can figure out what the key points are section by section. Okay, we started with 3A. The whole thing deals with percents and decimals and that sort of thing. So we want to know how to go back and forth, percents, decimals, fractions. The key here, of course, is going between percents and decimals. So if I start with a percent to go to a decimal, I get rid of the percent sign, I move the decimal 2 places to the left, and then fill in any zeros. So 2.38% becomes 0.0238. If I want to go from a decimal to a percent, if I have 3.71, then I will move the decimal 2 places to the right and add the percent sign, so 3.71 becomes 371%. Okay, this is the basis of everything we're doing for this unit, this percent equation, and you will use this equation when you are doing solving direct percent problems, and you'll use the same thing when you get into the consumer price index. You just replace your reference and compared values with CPIs. Okay, so the percent equation, and you need to know this, and the percent times the reference value equals the compared value. And remember that multiplication is the word of, equals is. So percent times reference value is compared value. Or you can say percent of the whole is the part. Okay, same thing. And remember that the percent and the compared value deal with the same thing, and then the reference value stands alone in the middle. Okay, so let's talk about percent increase. The formula is 100%. This, of course, is your reference value, plus the percent increase. So you might be a meal plus a tip, or an item plus tax, or something of that nature, or the price is increased by 40% over something before. Percent decrease, which is less than, is you take the whole reference value and you subtract out the percent decrease. So an item minus a sale percent, or a discount, or something of that nature. Now I put this in here because it's just to let you know that percent is times is percent as a decimal. So if it's 120% more, then that's the same as 1.2 times more. Okay. All right, absolute change is a number. The example in our notes we did with Lake Travis about the increase and the decrease in the lake levels. And you just do the compared value minus the reference value. Now be careful on this, because your compared value is not always the largest one. It's what is being compared to what. So your absolute change, if it's positive, that means it's an increase. If it's negative, it can be a decrease. And the decrease you can write as the absolute change is -12, or you can say it is decreased by 12. Either one of those mean the same thing. Then the relative change, or difference, is the absolute change divided by the reference value. So it's the compared value minus the reference value divided by the reference value. And remember, when you're doing this in your calculator, you're going to put the whole thing in the numerator in parentheses divided by the denominator. And then this number you change to a percent. Okay, we talked about 3 different abuses of percent. The first one is a shifting reference value. This is, I think the example we used was a pair of jeans that was 40% off and then an additional 20% off the sale price. That does not mean you get 60% off. You get 40% off the original price, and then that shifts the reference value, that sale price, then you take 20% off of that. A discount more than 100%, you can't lose more than 100% of your body weight. And averaging averages. Just looking at the averages isn't enough because you don't know how that average is calculated. And so the example that we did in class was about the batting averages in the first half of the season versus the second half of the season. If it's 60 and 40, it doesn't necessarily mean that it's 50. It depends on how many at-bats there were. Okay. All right, well, that's all of 3A. Then we went into scientific notation. And my key to success on this is to make sure you know how to use your calculator. Okay, scientific notation is A times 10 to the n, where A is a number between 1 and 10, and n is an integer. Now, we looked at the chart of the powers of 10. If this is a positive number, then it is a large number, a number larger than 1. If it's a negative number, then it's smaller than 1. And the other thing that we talked about on there was how to translate words into scientific notation. A billion is 10 to the 9th. A million is 10 to the 6th. A trillion is 10 to the 12th, that sort of thing. A thousandth is 10 to the negative 3, and so on. So knowing those will be helpful. But especially know how to use your calculator. Okay. Now, energy comparison is where we combined our dimensional analysis and using it with scientific notation, because our energy was being given to us in joules, and using those joules, they're in powers of 10, those units of energy. And the key to success on that, let me find it real quickly, is knowing, I should have gotten this out before I started, is knowing that chart. Knowing your energy comparison chart. And what we did before was I showed you how I did it because I need help writing these out. The table as it is gives me a little bit of trouble, so I just abbreviate it. This is the energy released by metabolism of 1 candy bar, which means 1 times 10 to the 6 joules is equal to 1 candy bar. And I just did this for myself as I was going through this. And I also, as I was going through this, I talked about energy release versus energy needed. And I don't know why necessarily I did that other than it is helpful. It was helpful to me, so that's how I did it. You will have this on the test if there is a problem that uses the energy comparisons. You will not have to memorize these. You'll just need to know how to use them. Okay, so what do? Well, we start with the given information, and you're going to end with the units that you want. So you're going to take the given information over 1. If it's, they want to know, I don't know, how many liters of oil or how many candy bars it takes to get something. So what they want to know is what your answer is going to be. So you're going to start out with your given information over 1, and then you're going to go to your conversion chart, and you're going to cancel the units. Whatever your units are here, you're going to have to get rid of down here. And this energy comparison is always going to be given in, you're going to have joules up here and some kind of comparison down here. And then you're going to have to do another one where you get rid of the joules until you get where you want to be. So it's doing that dimensional analysis using these equivalent fractions to cancel out the units, however many times it takes. Okay, then we went into comparing quantities, which is 3D and 3E. And to compare quantities, you always just take the larger divided by the smaller. Now I put a notation on here. When you're looking at scientific notation, look at the exponents. The larger exponent is the larger quantity. Okay, then we talked about cost due to inflation. And normally they want to know, if you look at the consumer price index, with the exception of 2009, it's continuously gone up. And 2009 was when we had a recession and it went down a little bit and rebounded the following year. But the consumer price index, chances are your reference value is going to be your older year. And their current year is going to be your compared value. We want to compare, if something cost $8 in 1984, what is it going to cost today? You can go backwards, but you make sure you read the problem correctly. Okay, so if you want the price in year Y, the price in your compared value, you take the price in year X times the CPI of the 2 years. And remember, you want to cancel units. So you want to take, whatever year is here, you're going to put the consumer price index here so that your units here are what you end up with. You will not be given this formula, so you will need to know how to do that in case you need it. Okay, the rate of inflation is just the relative change formula from 3A. Only you're going to use CPIs. So the compared CPI minus the reference CPI over the reference CPI. Again, that formula will not be given to you, but if it's a rate of inflation, it is just a relative change. Okay, Simpson's paradox, we're not going to worry too much about that. The false positives and negatives. There are 4 options for whatever it is. You're either positive or you're negative, and you test positive or you test negative. The true results are when I'll use the example that we did in class or on the review. If you have lupus and you test positive for lupus, that is the number here. Or if you don't have lupus and you test negative for lupus, that is also a true value. So these are the ones that are accurate out of your total participants, and these are the ones that are inaccurate. These are the ones that you do have lupus, but the test shows you don't. This is when you don't have lupus, but you tested positive. And then you have your totals of tested positive, tested negative, and whether or not you have it or don't. Okay, and of course, these two add up, and these two add up, and you add across, add down. Okay. All right, well, then we did a couple of examples that I'm hopeful that you wrote down, just some things that I thought we might want to go over. The first one is, and I said in class, I'm sorry to bore you again with it. After all this time, I hadn't been in a restaurant since February, and one of my favorite restaurants is Kirby Lane. So they had a patio, and one day when it was nice and cool, a friend of mine went and had lunch out there. It was delightful. It was as wonderful as I remembered it being. The bill, including a tip of 20%, was $98.50. So how much was just the food? Okay, well, here's how we would approach this. Our reference value is the cost of the food because the tip is based on that. All right, and these were just some guesses from the class. So I know that the food plus the tip is $28.50. The tip is based on the food. So this is 100% of the reference value. This is the food plus 20% of the reference value is $98.50. So 120% of the food is $98.50. And notice how I start from this big problem and I kind of whittle it down. I don't go immediately from here to an equation. I need something visual to help me get there. So 120% of X is $98.50. When I change this to a decimal, 1.2x equals $98.50. And when I divide by 1.2, I get 82.08 is the cost of the food. Now I'm going through these kind of quickly. If you want to go back and look at them or screenshot or whatever it is, just go ahead and do so. Okay, then we did some comparisons of cars. So I looked at two completely different kinds of cars. The cost of a Tesla and the cost of a Honda Fit. All right, so what is the cost of a Honda? Well, that is going to be, I know the price of the Tesla, so that's going to be my reference value. It is 20% of the Tesla, which means it's 0.2 times 90, which means it's $18,000. Okay, the Honda is what percent of the Tesla? Most of us, if the discount is, if it costs 20% of the Tesla, it is 80% less than. Okay. And again, you can do that with the circles if you want. Okay. But now this is where it became important. Because here, if we're talking about, we want to know the Tesla is what percent more than the Honda. That means we are switching our reference value and our compared value. If it's percent more than the Honda becomes our reference value. And we're comparing the Tesla to the Honda. Well, we know what the Honda is, so we're just going to use the relative change formula. So the compared value now is 90 minus the reference value of 18 divided by 18, remembering to put it all in your calculator, and you get 4. Well, of course, you wanted to turn that into a percent, so you find that the Tesla is 400% more than the Honda. Okay, then we did an energy conversion. We wanted to know how many candy bars would need to be consumed to supply energy for the U.S. for 1 month. Okay, well, 1 month is where we start. That is our known value. Well, I don't have anything on my conversion chart that deals with a month. Everything is dealing with years or days or something like that. And talking about energy for the U.S., if I look at energy for the U.S., it's given as a year. So the first thing I have to do is take that 1 month and convert it into years. So of course the months go on the bottom, the years go on the top. The equivalency is 1 year is 12 months. Now I'm going to get rid of that year and get into the energy. So I'm going to use the energy consumed for the U.S. in 1 year. So 1 year is equivalent to 1 times 10 to the 20th joules. Okay. Then I need to get rid of my joules, so I have to look at the conversion for the candy bar. 1 candy bar is 1 times 10 to the 6 joules of energy. And this is good because now everything cancels out, and what I want to end up with is candy bars. So candy bars goes at the end. The only thing I have left in the numerator is 1 times 10 to the 20th candy bars. And in the denominator I have 12 times 1 times 10 to the 6th. When I put that in my calculator, I get 8.3 times 10 to the 12th candy bars. Now, if the question doesn't specify, you can leave it like that, or you can write it as 10 to the 12th is trillion, so an 8 and 3 and 3, 6, 9, and 10 more, 11 zeros, or you can write 8.3 trillion, and make sure that when you're looking at the test, you understand how the answers are required. Okay, and then the last question that we dealt with was dealing with a false positive and negative, and we did it with lupus because a friend of mine had just been diagnosed with lupus. So either when you go to get tested for lupus, either you have it or you don't, and the test results are either positive or negative. So in this situation, the people who had lupus and tested positive was 90. People who had lupus and tested negative was 10. People who did not have lupus but did test positive was 5. People who did not have lupus and tested negative was 200. When you add those columns, you get 100 and 205. When you add the rows, you get 95 and 210. And you get that the total number of people tested was 305. Now, if you're given a table like this, I always like to mark what each of these means to help me out. This number is the total tested positive, total tested negative, total with lupus, total without lupus. And then you can answer any question just by going in and retrieving the numbers that you want. Okay, what percent of those tested positive actually had lupus? Okay, so I need those who tested positive, which is 95, and I'm going to find a percent of that. So that will be my reference value. Actually had lupus, that would be my 90. So what percent of the 95 who tested positive actually had lupus? And then I just do my arithmetic and I get 94.7%. Okay, then I said, well, what percent of those who did not have lupus tested positive? So I'm looking for, these two are my reference value. The percent that tested positive, my reference value is those who did not have lupus. So there's 205 for my reference value. So X times my reference value equals the tested positive. So of those who did not have lupus, who tested positive, were 5. Okay, and once again, this is your basic percent equation. X times 205 equals 5, so X turns out to be 2.4. And then lastly, what percent of those tested had lupus and tested negative? Okay, the number tested was 305. Those who had lupus but tested negative, there were 10 of those. So X times 305 equals 10. When I divide by 305, I get that X equals this big old long decimal. Now you want to pay attention to rounding on this. If it asks, you first of all want to change it to a percent. If you round to the hundredths place, it's 3.28. If you round to 10, it's 3.3. So be careful with your rounding. Okay, you have lots more practice problem on the review provided by the department. This is just a summary to help get you started. And so good luck.